The sum to product formula is helpful here because I honestly don't have a reference triangle for 5 pi over 12 or 1 pi over 12. That's just a little too specific for me. Let's see. I didn't think about this beforehand, but what is 180 divided... What is it, 15? Divided by 12? Yeah, it's 15. So... groups of 15. Anyway, I don't have a reference triangle for that. So I have cosine. I'm going to pick out this one. Let me just circle the one I'm going to use. This one right here. Okay. And that says that I can say 2 cosine and add the u and the v together. So I'm going to do that. I'm going to say 5 pi over 12 plus 1 pi over 12. That's the u plus v. And then times, not anything else in there, like I tried to do before, cosine of the same order. U take away v. 5 pi over 12 take away 1 pi over 12. And this is going to be a lot more manageable because now I have 2 cosine 6 pi over 12, which you may recognize to be pi over 2, times the cosine of 4 pi over 12, which you may recognize to be pi over 3. So if I have 2 cosine pi over 2 cosine pi over 3, I'm well on my way. Shall I draw it? Do I need it? Let's draw it just for fun. There's pi over 3 anyway. That's 60. It opens up on the square root of 3. 30 opens up on 1, 2. Okay. So let's go ahead now. 2 times the cosine of pi over 2. What is that? Oh man, that's 0. So this was all for nothing? Is that what you're telling me? I'm going to find this anyway. Cosine pi over 3. That's 1 over 2. So I get 1 times 0 is 0, but at least I know it's 0. Before I didn't know it was 0. Now I do. Okay.